This is the Ghazipur landfill in Delhi, India. It's almost 20 stories high, and it often collapses, killing the waste pickers that work there. Last year, when temperatures hit 43 degrees Celsius, it caught fire 3 times in a month and burned for 48 hours straight, exposing the city to harmful particulate matter. This happens because the organic waste in the landfills decomposes to form methane, a highly flammable and potent greenhouse gas. And as we have more and more heat waves, the problem will only get worse. This landfill in Buenos Aires causes the pollution equivalent to roughly 1.4 million cars, or the same as roughly 2 average-sized coal-fired power plants. Landfills like these are major contributors to climate change because of the methane they emit. Methane comes from everywhere in the world, but in developing countries, emissions are expected to double by 2050. Methane is therefore the Global South's climate challenge because it's a development challenge. As poor countries get richer, their demand for food and consumer goods will increase, and so will the waste they generate. If we're going to keep warming under 1.5 degrees Celsius, we need to reduce methane emissions in half by 2050. But we must do so without getting in the way of quality of life improvements in the Global South. That's why in 2022, I became the CEO of the Global Methane Hub, a major philanthropic effort focused on methane mitigation based out of Santiago, Chile. Methane doesn't get the same attention as carbon dioxide does, but it's contributed to nearly half the warming we've experienced to date. It's short-lived, so if we stop emissions now, its warming effect will soon follow. If we only focus on carbon dioxide emissions, we're only going to get half the temperature reduction these next 2 decades. Mitigating methane, therefore, is the fastest, most efficient way to reduce temperature within our lifetime. But don't get me wrong, this is not about delaying action on fossil fuels. 40% of methane emissions come from fossil fuel extraction. But today I'm going to talk about the other 60% that not a lot of people talk about, which is food systems emissions, food production, and food waste. I'm a biochemical engineer, a professor, and I was formerly the environment minister for Chile. Before I got into politics, when I was a graduate student at the University of Iowa, I'd work with NASA tracking air pollution across continents using aircraft and satellites. When I got back home, I used those same tools to develop air quality forecasting systems that helped change the way we did things. And we had a radical drop in air pollution levels. But during my tenure, a large landfill caught fire, and it put the whole city of Santiago under a black cloud of carcinogenic soot. It was an event our model couldn't predict. It was methane again. Another landfill nearby smelled so terrible that neighbors protested for weeks, and they were right. Nobody deserves to live like that, and we could do something about it. The organic waste in landfills is one of the most visible sources of methane, literally. And food systems, food loss and waste is a big part of the problem. 50% of all food systems emissions come from food that nobody ever eats. In sub-Saharan Africa, 37% of all food that's produced is either lost or wasted, either because there's not enough infrastructure to store it, to transport it, or to keep it from spoiling. The other part ends up in the trash. And when that organic waste is concentrated in the landfill, we can see the methane this waste emits from space. The NGO Carbon Mapper is a public-private partnership that's leveraging technology developed by NASA scientists to pinpoint methane sources across the world. They started with aircraft, and soon they'll be up in a satellite. Seeing methane this way contributes to real mitigation. And the Sunshine Canyon landfill in Los Angeles is an example of this. Airborne methane data inform basic operational improvements, such as covering the daily trash with liners, which led to a radical drop in emissions, 60% lower emissions, and the complaints from neighbors disappeared. Now, we decided to take this effort globally. And with our colleagues from RMI, the Cleaner Task Force, and Carbon Mapper, we put together the Waste Map, the Waste Methane Assessment Platform, which links satellite information, NGOs, and local governments to intervene. With other colleagues, we're working in the biggest landfills in the world, including the one you saw in Delhi, the one in Buenos Aires, and of course, the city of Santiago, where I live. Pinpointing methane sources allow us to stop existing emissions, but they also help prevent new emissions from occurring too. And it starts with organic waste diversion. We could do a lot of different solutions, like composting, we could do food banking, or we could turn that organic waste into food, like what my dog Rusio eats, made from soldier flies that grew on food waste. Now, don't worry, I would never feed my dog anything I wouldn't eat. But food waste is not the only problem. What we eat also has big impact. And in that, cows. Raising cows for dairy and meat is the single largest anthropogenic source of methane. That's right, cow burps. The scientific name for that is enteric fermentation. If you feed an animal low-quality food instead of high-quality food, a lot of that energy doesn't go to create milk, it goes to digestion and cow burps. So an animal in sub-Saharan Africa causes 5 times more emissions than one in North America per unit of milk, because it's usually eating suboptimal food. So improved breeding, feeding, and animal welfare could reduce emissions and improve income for farmers. But we have to do a lot more about cow burp emissions, and that's why we're launching the Enteric Fermentation Research and Development Accelerator, a $200 million effort that will focus on reducing livestock emissions, and it will be the biggest effort of its kind. You may have heard some scientists are feeding algae or seaweed to animals to change their metabolism to reduce methane emissions. And there's a whole bunch of solutions like that, but for each one, we have to know, is it safe? Does it last? And how it will perform when it's not in optimal settings, like when the animal is out in pasture all day instead of being fed. We hope that this research initiative will deliver the scientific breakthroughs we need to reduce livestock emissions and keep 1.5 alive. When I was minister, I would often hear from my colleagues, why should we act on climate change if it was the rich countries that caused the problem? And it's partly true. Emissions have historically come from developed countries, but they're rising fast in the developing world. We don't need to follow a path we know will lead to higher emissions and pollution. We could cut across straight into sustainable solutions. But what I heard from colleagues was based on the premise that reducing emissions will make our day-to-day life worse because of all the things we have to do without. But this is a false narrative, and it's not the case for methane. Methane is a global problem, but the benefits are felt where action is taken. Vulnerable communities that aren't exposed to the constant threat of dump fires or foul smells. Landfills that aren't filled with rotting organic waste that can instead be turned to food or fertilizer. Farmers that are already under the threat of climate change could gain income and resilience because of better, more efficient livestock and rice production. You and I can't do much to create zero-emission cement or change grids across countries or continents. Well, some of you can, but not everybody. But 60% of our emissions from methane come from our food, our trash, and our neighborhoods. And taking action on reducing methane now is a big step to saving the planet. And we can start when we get back home, composting our food. We'll see the benefits: better living conditions, cleaner air, improved food security, right here and right now. Thank you.